Good afternoon, everyone. Let us start this session. So, in the last lecture, we have seen the ladder friction. So, this is the second problem on the ladder friction. So, here one ladder AB is resting against the vertical wall at point B and on the ground at point A. So, A and B, these are two contact points of the ladder. The weight of the ladder given, it is 100 Newton, and coefficient of static friction is 0.15 for all the contact surface, that is at point A and B. And question is, we have to calculate the range of values of P, that is the external force, for which the equilibrium is maintained. So we have to find out the range of values. That means we have to find out the minimum value and the maximum value. Okay, so if you apply the force P between these two values, then the given equilibrium is maintained. If the value of P is less than P minimum, for time being assume the P minimum value is 20 Newton, P maximum is 40 Newton. Okay, and if we apply the force at point P, it is less than 20 Newton, then the ladder, it will start slipping. That means the point B, it will move in the downward direction, and point A, it will move on the leftward direction. Suppose the P value is greater than 40. Suppose we apply the force 45 Newton. Then the ladder, it will start slipping in the upward direction. That means the point B, it will slide up the plane, and the point A, it will slide on the right side. So we have to find out the limiting values. So limiting value is P minimum. So we have to find out these values by calculation. So P minimum and P maximum by using the conditions of equilibrium. So this is the given diagram where the force P is applied on the ladder at distance 20 centimeter. P is exactly horizontal. Point A is at distance 16 centimeter from this corner, and point B is at 40 centimeter from this corner. So these are the dimensions given. So we will consider the case 1 where P value is equal to P minimum. So at this condition, ladder will be on the verge of motion, verge of slipping, and the point B will try to slide down the plane, and the point A will slide on the left side. So this is the impending motion. When we consider P value, it is the minimum value. So for this condition, we will draw the free body diagram. So the self weight of the ladder, it is given in the problem as 100 Newton. So this weight, it will act exactly at the center of gravity. So this is the point A, this is point B. So from this point, weight will act vertically downward. So this is 100 Newton. Then at the contact point B, okay, first show this force P at distance 20 centimeter. So this center of gravity, its distance from the point A, so this distance will be half distance of the total ladder. So total distance is not given. So we can find out this distance from the given dimensions. So this is 40, this is 16. So this is the hypotenuse for this right angle triangle. So let us assume this to be x. So we can find out x, this is equal to 16 square plus 40 square. So the total length of the ladder is 43.08 centimeter. So this distance from A to G, so it will be exactly half of this distance. So this is 21.54. Next, we have the P force at 20 centimeter. Okay. So actually this P force, if you observe this, then if this is the center of gravity, then this distance will be exactly half if you use the similarity of triangle. So this is 20, so this will be 20. That means center of gravity and the force P, they are acting at the same point. So we can show this vector exactly at the center of gravity. So this is the P minimum force. Next, at the point B, show the reaction. So here you will have one reaction, which is the normal reaction. So this is the NB. So this is the reaction NB. Then at point A, this is vertical reaction. So this is the reaction NA. Okay, now consider the impending motion. At the minimum value of the force P, the tendency of the ladder will be to slide down. So point B, it is having the impending motion in the downward direction, and the point A having the impending motion on the left side. So here impending motion is like this, and therefore friction at this point will be exactly opposite to the impending motion. So friction is upward, and this is equal to 0.15 into normal reaction NB. Similarly, at the point A, its impending motion is on the left side, and therefore friction will be on the right side. So this is equal to 0.15 into normal reaction A. So we have shown all the forces, force P, then weight, normal reaction, Na, Nb, and the frictional forces. Now use the condition of equilibrium. So summation Fx is equal to 0. So for summation Fx, we have the first force 0.15. into normal reaction A, then minus NB and plus P minimum. So this is equal to 0. So from this, you can write the equation for P minimum. This is equal to NB minus 0.15 Na. So you can consider this is equation 1. Then use summation if y is equal to 0. So for the summation if y is 0, Na is positive, then plus 0.15 NB minus 100. This is equal to 0. So you will get the equation Na plus 0.15 NB. This is equal to 100. So take this equation 2. Now use the third equation, that is the summation of moment. Summation of moment by all the forces about the point A, and this is equal to 0. So to take the moment about the point A, that is about this point, we have to find out the perpendicular distance. So if you observe the original diagram, then perpendicular distance for NB is given. So for the NB, distance is 40 centimeter. Then for P minimum, the direct distance is given, which is 20 centimeter. But for this 100, which is the weight force, the distance is not given. So we have to find out this distance. So you can extend this line. So if you use the similarity of triangle, then this line, it will bisect this horizontal distance. So total is 16. So this is 8 centimeter and this is 8 centimeter. So for 100, we have the perpendicular distance 8 centimeter. So just I will show that distance on this free body diagram. So this is 8. This is also 8. Total is 16. And for this NB, this distance, it is 40. So your equation is, we have to take the moment about the point A. So this is your moment point, point A. So NB into distance is 40. This moment is anti-clockwise. Next is this point 15 NB, friction force. It is acting in the upward direction and its perpendicular distance is 8 plus 8, 16. So 0.15 NB into 16, and this moment is also anti-clockwise about the point A, so it is positive. After this, we have this 100 Newton. So 100 into distance is 8 centimeter. And this moment by 100, it is clockwise. So it is negative. Next, we have this P minimum. So P minimum, it is acting at the point G. So its perpendicular distance. So this is the perpendicular distance. And it is given directly as a 20 centimeter. So that moment will be P minimum into 20. And this moment is also clockwise. So it will try to rotate the ladder AB at point A in the clockwise direction. So it is also negative. And moment by this Na and this friction force, both the moments are same because two components or two forces, they are passing through the point A only. Now equate this equation to 0. And from this equation, you will get one equation in terms of NB and P minimum. So that equation will be, or you can put this value P minimum NB minus 0.15 NA in this equation. So 40 NB plus 2.4 NB minus 800 minus NB minus 0.15 NA. So I am replacing this value by this complete value equation into 20, and this is equal to 0. So here you will get 42.4 NB minus 20 NB, this value, then plus this 0.15 into 20. So this is 3 NA, and this is equal to 800. So if you add these two values, so actually this is negative. So 22.4 NB plus 3 NA, this is equal to 800. So you can take this equation 3. Now this equation Na plus 0.15 NB and this equation, they are the simultaneous equations. So I will write here Na plus 0.15 NB, this is equal to 100. Second equation is 3 Na plus 22.4 NB, this is equal to 800. Solve these two equations simultaneously and get the value of Na and Nb. So Na is equal to 96.58 Newton. Nb is equal to 22.78 Newton. Okay. Now put this value in this equation so that you will get the value of P minimum. So P minimum from equation 1, this is equal to, where NB value is 22.78 minus 0.15 into 96.58. So it is 8.29. Okay, so this is the minimum value so that we can maintain the given equilibrium. So this is the case 1. Now we have to find out the maximum value, because finally we have to find out this range of values P minimum to P maximum. So right now we have calculated the P minimum. Now we have to find out the P maximum. So for the P maximum, so P value will be P max. So we have to observe the direction for the impending motion. So for the maximum value, the ladder, it will start slipping, and this point, that is a point B, it will slide in the upward direction. So impending motion for the maximum condition is in the upward direction, and the point A, it will slide on the right side. So this is the direction for the impending motion. Now depending on this direction, draw the free body diagram. This is the weight force, which is equal to 100 Newton. Then this is the external force, which is a P max. Then at point B, there is a normal reaction. So normal reaction, it will send. So this is NB. Then this is normal reaction NA. Now show the direction for impending motion. So for the point B, its impending motion is up the plane. So the friction force at this point will be opposite direction to the impending motion. And the value is 0.15 into NB. Similarly, the point A, its impending motion is towards right. So the friction force will be in the opposite direction. And this is equal to 0.15 N. So this is your complete free body diagram. Now use the condition of equilibrium. So take summation, Fx is equal to 0. So for the Fx 0, so for the Fx 0, we have the NB on the negative side, so minus NB. Then P max on the positive x side, so plus P max. And this 0.15 NA, it is also on the negative side, so minus 0.15 N. And this is equal to 0. So from this equation, you can write the equation for P max, which is equal to NB plus 0.15 NA. So consider this is equation 1. Now use second condition, summation Fy is equal to 0. So for the summation Fy, this 0.15 NB on the negative side, so minus 0.15 NB. Then this is minus 100 and the plus N. This is 0. So from this, you will get the equation as Na minus 0.15 NB. This is equal to 100 Newton. So take this equation 2. Use third condition. So that is summation of moment by all the forces about the point A. This is equal to 0. So for that, we have to find out the perpendicular distance. So for this force, perpendicular distance is nothing but this total distance, which is equal to 16. So moment will be force is 0.15 NB into distance is 16. And that moment, if you observe the direction of rotation, so it is a clockwise movement, and therefore it is negative. Next, we have the NB. For the NB, this total is the perpendicular distance, so which is a 40. So moment will be NB into 40, and this is positive because it is anti-clockwise about the point A. Next is the 100 into its perpendicular distance. So just extend this line. So actually this line, it will bisect this line. So this is 8 and this is 8. So this distance with respect to the point A, it is equal to 8 centimeter. And this moment by 100, it is also clockwise. So it is negative. Next, we have the P max force. So for the P max, its distance with respect to point A. So it is given as a 20. And therefore, the moment will be P max into 20. Now this moment by the force P, it is a clockwise. So this is negative. Next, moment by Na, that will be 0. Moment by this point 15 Na, it is 0. And this is equal to 0. Now from this equation, you can take the NB common and get one coefficient for the NB. So this is 37.6 into NB minus 20 P max, and this is equal to 800. Now put the value of the P max, which is NB plus 0.15 in this equation. So this equation we can write 37.6 NB minus 20 into NB plus 0.15 Na. This is equal to 800. So from this you will get 17.6 NB and minus 3 Na. This is equal to 800. So this is your third equation. Solve the equation 2 and equation 3 simultaneously. So just I will rearrange the equation. So this is minus 0.15 NB plus Na, and this is equal to 100. So this is your second equation. So from equation 2 and equation 3, you will get the Na and Nb. So Na is equal to 109.62 Newton. Nb is equal to 64.14 Newton. Now put these two values in this equation. That is equation 1. And therefore P max value, this is equal to NB is 64.14 plus 0.15, Na is 109.62. So you will get the P max, this is equal to 80.58 Newton. So this is the maximum value. If you exceed the P value beyond 80.58, then you can observe the complete motion for the given ladder. Up to this value, ladder will be in the equilibrium or it will be on the verge of motion. Verge of motion means it is the limiting condition for the equilibrium. After that, body will start the motion. So your final answer, finally we have to find out the range. So your answer will be range of values of P to maintain the equilibrium. So P minimum, P max. So this is equal to P minimum is 8.29 Newton and P maximum is 80.58 Newton. So this is your final answer. Okay, so this is the range of values for the equilibrium.